Welcome back, Chem Squad. Here's your next round of video notes at home, and today's topic is going to be percent composition. And percent composition is another way of looking at exactly what a molecule or a compound is made of and what percentage that's made of. And we're going to look at it based on its mass. And this is going to build off the law of definite proportions, which we've talked about before, which tells us that when we have a compound, it has a constant composition. It's a pure substance, which means, for example, when we look at water, we know that water is H2O, telling us that there's always two hydrogens for every one oxygen. And that proportion or composition is not going to change. So that ratio is always a 2-to-1 ratio. But that does not necessarily mean that hydrogen makes up the most mass. So we're going to actually do a little bit more math here based off our formulas. So let's go ahead and write this down in our notebook given on the page given to you by your teacher. And the first example we're actually going to look at is water. So we have water here, which we know is H2O, and there's a model that is showing us that we definitely have our two hydrogens and one oxygen. And this shows us that based on their size or their mass, oxygen is much larger than hydrogen. So even though there's more hydrogen in water than oxygen, hydrogen does not make up most of water's mass. So we're going to figure out what percentage each one of these elements actually makes up or composes for water. The first thing we're going to have to do is actually find the formula mass. So we're going to go back to what we talked about last week and find the formula mass for water. And to do that, we need to know how many of each type of element is present in our compound. So looking at water's formula, we know that hydrogen, if we're just going to focus on hydrogen, we have two of them, and the mass of each one, which we're going to get from our periodic table. So get your periodic table in front of you and find hydrogen's mass. And if we look it up on the table, we're going to see that hydrogen has a mass of 1.0. So therefore, the mass coming from hydrogen is 2.0. Oxygen does not have that subscript behind it, so that tells us that there's only one. And if we look up oxygen on the periodic table, it has a mass of 16. So therefore, the mass coming from oxygen is 16. So to get our formula mass, we're going to add both of those together, and we're going to get a total mass of 18 grams. So that part should be reviewed. We know how to find the formula mass. So the overall mass of our substance, our formula mass, or sometimes we're going to abbreviate it as GFM, gram formula mass, is 18 grams. Okay, so our next step here is we want to figure out what percentage this is. And this is calculating a percentage just like you do in anything else that we've done. It's not a weighted percentage, so it's actually easier than some of the things we've done. But we're going to actually look at the percentage of each one. Okay, so if we want to find just the percentage of hydrogen, we already know, based on the work we did, that 2 grams came from hydrogen. And our total is 18 grams, so our total formula mass for the substance. So what we're going to do is take the mass of each element and divide it by the total mass, which is our formula mass in this case. And when we do that, we get a fraction of 0.111. And this is actually our percentage. So we're going to turn it into a percentage by multiplying by 100. And that gets us a total of 11.11%. So this tells me that in water, its percent composition is 11.11% hydrogen. Okay, but we're actually going to find it for all the pieces involved. So we're also going to look what is our percentage for oxygen. There's a couple ways you can do this. You can take 100 and subtract 11.11, or we can continue the way we initially set up, which is what we're going to do. And we know that 16 grams is coming from oxygen in water, and our total is going to be the same, so it's still 18 grams for our total. So we're going to divide those, and when we divide that, we get 0.8889, and again, that is a fraction, which is what we want, and we're going to multiply that by 100, to get to our percentage, and our percent for oxygen is 88.89%. So now we have our two percentages, and even though there's only one oxygen, this shows us that water is primarily made up of oxygen, not the hydrogen when we look at its mass. Also, a way to double check so that we know that we did this correctly is if we add up our percentages for all the stuff that we have in there, this should add up to 100%. So if that doesn't end up getting to 100%, that tells us that something is off in our calculations and we need to go back and recheck it. All right, let's look at this with a different, more complicated compound. Okay, so aluminum nitrate. Again, the first thing you're going to have to do is find the formula mass of this substance. All right, so we're looking at this, and we know that we have one aluminum. And looking on our periodic table, we have a mass for aluminum of 27. 27 grams coming from aluminum. The next element we come to is nitrogen. And if I distribute my 3 through the parentheses there's no subscript next to N, so that means I have 3 of them. And if I look up on my periodic table, the mass of nitrogen is 14. So 3 times 14, we have 42 grams coming from nitrogen. And the last element is oxygen. And distributing my 3 through the parentheses again, I have 3 nitrates, which means I'm going to have a total of 9 oxygens. So 3 times 3 there is 9. And oxygen's mass is 16. So 9 times 16 gets me a total of 144. And if I add all these up to get my formula mass, I end up with a total of 213 grams for my formula mass. So my GFM for aluminum nitrate is 213 grams. And that's what I'm going to use to calculate my percent composition. All right, so if I want to find my percent composition for just the aluminum part, same thing we did with water. We're going to take the mass we have coming from just the aluminum, so divided by the total. So in this case, we have 27 grams from aluminum divided by my total, which I calculated my formula mass, which is 213, and that gets me a percentage of 12.68%. All right, same thing with nitrogen. Nitrogen, we calculated the total mass from nitrogen being 42 grams over 213. And again, when you do this, you're going to multiply by 100 because you end up with a decimal. We end up with 19.72% nitrogen. All right, and oxygen, the last one, and oxygen, notice we have a whole bunch of them. This should be the majority of our mass. We have 144 grams from oxygen out of our total of 213, which gets us to 67.60%. So looking at aluminum nitrate, these percentages would be your percent composition. Aluminum nitrate is 12.68% aluminum, 19.72% nitrogen, and 67.6% oxygen. And again, double check by adding up all of your percentages, which should get you to 100%. So there we are for percent composition. Please bring any questions you have for class tomorrow, and good luck, Chem Squad out.